Hello everyone, welcome to Shibi's chemistry classes. Today we are going to start bases. We have already completed acids. Now in today's session we are going to see what are bases. So first we have to define it. A base is either a metallic oxide, metallic hydroxide, or ammonium hydroxide that reacts with hydronium ion of acid and acid to give salt and water only. So what is the definition of a base? A base is either a metallic oxide, metallic hydroxide or ammonium hydroxide that reacts with hydronium ion of an acid to give salt and water only. Now I will take some example to make this definition more clear. When I said metallic oxide, so what is a metal oxide? We know that all metals form basic oxide. So that is why under bases what we are going to study metallic oxide or hydroxide. Say lead is a metal and when it combined with oxygen it gives oxide. So metallic oxide or metallic hydroxide. Hydroxide means OH group or hydroxyl group. So metal in combination with hydroxyl group give metallic hydroxide and here when it combined with oxygen give metal oxide. Most common example is of sodium. Sodium valency is 1, oxygen valency is 2. When we write the formula, we will cross the valencies and we get Na2O. So this is a metal oxide and its hydroxide is NaOH. Similarly, K2O, KOH. Many are there. Calcium oxide, calcium hydroxide, ammonium hydroxide. So these are some of the bases that we have to study in this. So bases are either a metallic oxide or metallic hydroxide or ammonium hydroxide that reacts with hydronium ion of an acid to give salt and water only. This is a base. When react with acid, give salt and water only. So word only is very important over here. If you are getting another compound along with these two products, then it is not a base. For a compound to act as a base, to come under the category of base, it is a mandatory requirement that it gives only salt and water. Nothing else could be there. Okay. So let's take one more example to make it more clear. This is lead oxide. This is lead oxide and when you react it with acid, this is a metallic oxide. You react it with acid. So what you are getting? A salt, water and one more product, that is chlorine gas. So do you categorize it as a base? Because in the definition what we are saying, base is a compound that when reacted with acid gives salt and water only. But in this lead oxide, when it is reacting with hydrochloric acid, apart from these two, salt and water, it is giving one more compound as a product, and that is chlorine gas. So this lead oxide do not comes under the category of a base. So that is why this word only is very important in this definition. So let's take a few more examples. Ammonium hydroxide base when react with acid gives ammonium chloride as a salt and water only. So this is a base. aluminium hydroxide. Valency of aluminium is 3. Reacted with HNO3 is nitric acid. So what you will get in the product side? Aluminium nitrate. Aluminium nitrate, salt and water. Balance it. 3 nitrate is there, so make it 3. So how many hydrogen now? Aluminium is okay 1, hydrogen 3. 3, so make it 3 over here. So it is balanced. Magnesium hydroxide on reaction with sulfuric acid gives magnesium sulfate and water. So you can see in all these definition examples, the definition is true because you are getting only salt and water. So yes, these compounds are all bases. Now when we are talking about base, one thing is to be discussed, that is alkali. It's a very important term, alkali. So these are all water soluble bases. See, all the metal hydroxides are, all the metal oxides are and hydroxides are insoluble except for sodium, potassium, calcium. See, sodium, potassium, calcium and ammonium ion. So leaving these 4, all the other metallic oxides and hydroxides are insoluble. So if you get oxides and hydroxides of these 4, then only it is a water soluble, like NaOH, KOH, CaOH twice and H4OH. So these 2 are highly soluble and these are less soluble. Highly soluble means in water, when ionized, it produces high concentration of hydroxyl ion. And so we know that acids give hydronium ion and bases give hydroxyl ion. So on ionization, these 2, they are strong bases. And why they are strong bases? When ionized in water, they give high concentration of hydroxyl ion. These 2 are less soluble. Rest, if you think of any other base, they all are insoluble. And say it is CuOH twice, MgOH twice, any other bases, they all are insoluble. So that is why these 4 are called alkalis. Water soluble bases are called alkalis. So we can say that all alkalis are bases. All alkalis are bases. But the reverse is not true. All bases are not alkalis. Like aluminium hydroxide, it is a base, but it is not alkali because it is insoluble in water. Similarly, copper hydroxide. Similarly, magnesium hydroxide. Just think of any other compound, any other base except these 4. They all are insoluble. So that is why we say that all alkalis are bases, but all bases are not alkalis. They all are base, but they are not alkali because they are insoluble. Now we'll classify bases. Classification. Just as we classified acids, similarly we have to classify bases also. First, on the basis of strength. On the basis of strength, it could be strong and weak. How we classified in acids, strong acids and weak acids? On ionization, the one which give high concentration of hydronium ion, that is strong acid, and the one which give less concentration of hydronium ion, that is weak acid. Similarly, a strong base, it undergoes almost complete dissociation in aqueous solution to produce high concentration of hydroxyl ion. Almost complete dissociation in aqueous solution to give high concentration of this hydroxyl ion. Similarly, KOH is also a strong base. On dissociation, it gives high concentration of OH minus ion. Weak base only undergo partial dissociation. And take example of weak base. We discussed just now ammonium hydroxide and calcium hydroxide. The weak bases, they undergo only partial dissociation, giving less concentration of hydroxyl ion. Next classification is on the basis of their acidity. Under acids, we have studied basicity, and in bases, we have to study acidity. So, what is the acidity of base? So, there in basicity, we discussed that it is the number of hydronium ion produced per molecule of acid, whereas in acidity, what we have to see? Acidity is the number of hydroxyl ion produced per molecule of base. It is the number of hydroxyl ion. This is hydroxyl ion produced per molecule of base in aqueous solution. So acidity is the number of hydroxyl ion produced per molecule of base in its aqueous solution. So it could be monoacidic base, diacidic base, monoacidic base, diacidic base, triacidic base. Mono means one hydroxyl ion is getting produced. So example of mono will be NaOH, KOH, NH4OH, NaOH, KOH, NH4OH. So all these on dissociation are producing one molecule of hydroxyl ion. So that is why they comes under monoacidic base. And diacidic, it produces 2 hydroxyl ion per molecule of this base. Like 2 molecule, we have to produce 2 molecule. Like calcium hydroxide. So on dissociation, it will give calcium 2 plus 2 hydroxyl ion, and this 2 hydroxyl ion will combines with 2 hydronium ion to with salt and water. So that is why it is diacidic base. By diacidic means the hydroxyl ion that is getting formed over here will combine with the hydronium ion of acid. Salt, acid plus base gives salt and water. So actually what is the reaction what is the mechanism that is taking place over here is this hydroxyl and hydronium ion. They are actually undergoing the reaction. That is why in case of base we are saying diacidic, monoacidic, triacidic. Mono means one hydroxyl ion, acidic means will react with the hydronium ion of acid to give salt and water. So this is monoacidic, this is diacidic, means 2 hydroxyl ion combined with 2 hydronium ion. So it is called diacetic. Triacetic, say aluminium hydroxide, triacetic, aluminium hydroxide, ferric hydroxide, 3 hydroxyl. On dissociation it will give 3 OH minus, and this iron will give 3 OH minus ion. So this 3 OH minus that is formed over here will combine with 3 hydronium ion of acid to give salt and water. So that is why it is called triacidic base. Now next we have to see the preparation of bases. So we know that bases are metal oxides or hydroxides. So definitely in the method of preparation we have to take metals. And so preparation method will involve the use of metals because bases are metal oxides or hydroxides. Let me write some examples over here. Metal oxides, hydroxides, NaOH, KOH, NH4OH. So see, in all these examples we are using metals. So definitely on the reactant side we have to use metals as one of the reactant. So first method is from metals. So one reactant could be a metal and another reactant only that we have to change. So if we want to make oxide, so we will react it with oxygen. If we want to make hydroxide, then we will change the another reactant to water. In one case oxide, in another case water, but metal will be same in both the case because it is metal oxide or metal hydroxide. So first method we will make metal oxide. So to make metal oxide, one metal we have to take and just react it with oxygen. So you will get metal oxide. Similarly, magnesium oxide. So to make a metal oxide, and metal oxides are all bases, we know that. So metal plus oxygen is metal oxide. So just combine both of them. The next method of preparation is metal will remain the same. Now we have to make hydroxide. So action of what? Water on metals. Action of water on metals. We'll take sodium, potassium, calcium because these are water soluble, no? We'll treat it with water and you'll get the respective hydroxides. NaOH, KOH, CaOH twice, balance the equation. The next method is by the action of water on soluble metal oxides. Soluble metal oxides, what are they? So all the oxides of sodium, potassium, calcium, they are soluble. So now next is the action of water on soluble metal oxides. Action of water on soluble metal oxide. So one correction I want to make, in the previous method of preparation, action of water on metals, hydrogen is also, let me correct it, no? Sodium, potassium and calcium we have taken. Action of water on active metals. And the previous one. Action of water on active metals. In this method, we have done this. I forgot to tell you the liberation of hydrogen gas also take place here. While treating water with active metals, hydrogen gas is released. Now next is action of water on soluble metal oxide. Action of water on soluble metal oxide. Now this is the third method of preparation, action of water on soluble metal oxide. Now what are soluble metal oxides? Oxides of sodium, potassium, calcium. So these are soluble metal oxides and we have to react it with water. And you will get the respective metal hydroxide or bases. Now next method is by double decomposition. Now what is this double decomposition? By double decomposition, we'll take a salt plus base. We'll take salt and we'll treat it with a base. And what product you are going to get? Basic hydroxide. A salt, any salt, say ferric chloride, copper sulfate, aluminium chloride, sodium chloride. So these are all salt. When it is treated with a base, alkali means water soluble base. In place, you have to take alkali, water soluble base, and you are going to get basic hydroxide and a normal salt. A normal salt. So this is example of double decomposition. So just take a salt, ferric chloride is a salt, react it with a base alkali, you will get basic hydroxide and a normal salt. Normal salt will be NaCl and basic hydroxide FeOH thrice. So this is a basic hydroxide and you will get it in the form of a precipitate. Precipitate is shown by this downward arrow. Next example, we will take copper sulfate. It is a salt and one base. And what base we have to take? Not all the base, only alkalis, water soluble base, and that is NaOH. The best example is NaOH. And you will get a basic hydroxide and a normal salt. Normal salt will be sodium sulfate. So normal salt is sodium sulfate and the basic hydroxide is CuOH twice and it is formed as a precipitate. So this is a double decomposition method for the preparation of base. Next is by the action of oxygen on metal sulfides. Next method of preparation is by the action of oxygen on metal sulfide. Metal sulfide say ZnS, Fes. Iron sulfide, zinc sulfide, lead sulfide, action of oxygen, and you will get metallic oxide. PbO, ZNO, FeO, PbO plus sulfur dioxide gas. By the action of oxygen on metal sulfides, you will get respective metal oxide, that is a base. Next is by decomposition of salt. By decomposition of salt. Say calcium carbonate is a salt. Decomposition means you have to apply heat and you will get calcium oxide and carbon dioxide gases released. Calcium oxide is a metal oxide and base. So these are some of the method of preparation of bases, and in the next video we will be seeing the physical and chemical properties of bases. Till then, have a nice day.